Uh, my name is Giannis Kaldis. I am a business consultant at Intrasoft International. I represent the PROPHESY project of the PROPHESY cluster. And we will be speaking about cost benefit and return on investment calculators that have been built specifically for general predictive maintenance applications, as well as the next step, which is the service optimization engine, the SOE, as we will see, which takes input from these calculators. First of all, let's say that PROPHESY had a dedicated work package specifically for producing a portfolio of solutions of general applicability, not necessarily within PROPHESY, but in more general predictive maintenance and Industry 4.0 factories of the future concepts. And the idea was to offer a tool set to the community, which would be free for life. Internally in the project, we also used this as input to the pilot demonstrator evaluation. We had use cases from Jaguar Land Rover and from Philips. We use these to create an ecosystem generally within predictive maintenance and start making these offerings public so that people can try them. And the general idea, of course, is define the constituent parts or modules, we call them service bricks, that comprise the solution that someone has. Then, assuming you have KPIs, obviously, the calculation through data-driven techniques. Then basic metrics that everybody in maintenance knows about, for example, overall equipment efficiency or effectiveness. Then cost-benefit calculators, which will be our point today. Propose some business models. For example, we have different business models proposed and different pricing strategies proposed. If you are a machine vendor and you see things differently from a factory operator, or if you are an industrial IoT integrator with knowledge in IT, you see things a little bit differently. So how these three view how they could make use of PdM, predictive maintenance, and then evaluate optimal solutions with the so-called SOE. And we have another module called Play with PROPHESY Sandbox. We will see that, where you can actually play with these solutions live in a version. So you will be, you might know that we have launched, apart from the project portal, the so-called PdM for Industry.eu ecosystem, which is different. We actually have a for Industry set of portals. So we have ZDM for Industry for zero defect manufacturing. We have Edge for Industry, Edge computing for manufacturing, and predictive maintenance for industry. So apart from seeing our use cases, as you will see on the left, we have the ability to visit and see our SOE engine in action and to see our calculators who are available, as well as on the right. You can actually star rate them. We expect your rating and we value your feedback. Of course, registration is free of charge for life. Let's see the theory first of all. First, you have to obviously select some KPIs, then measure indices. Then the difficult part, which is how to translate those into monetary impact. You need to provide information in the asset because the calculator can't possibly know the specifics of your machinery. We strongly advise that you use our tools to have an analytic cost breakdown, and then the tool can compare the before-after situation, as well as, and that's most important, to compare against the rough estimate of best-in-class, what other cases are doing or what you could achieve in the optimal case. Then it's a matter of using typical financial indices to calculate the net present value, internal rate of return, discounted payback, and so forth. You can select the appropriate business model for your case and the appropriate pricing that we propose based on our experience. Several alternatives exist. And to try to optimize your solutions through the service optimization engine. So once you join PdM for Industry, and you can just do it with a click, sign in with Google or Facebook or LinkedIn or whatever, you will be able to see the PdM specific calculators, and you can also request to download them offline. So the calculators are available in two forms. On the right, you will see the typical web form created in JavaScript, and it's quite obvious. You have to fill in the data and press calculate, and you will get the results. Whereas on the left, you will see the equivalent, the exactly same implementation in an Excel spreadsheet, which you can download offline. You can see all the cells because the formulas are not hidden. And since in Excel form, someone cannot know which cells to fill in, it is clearly explained that when you see a yellow cell, it is input, and you put your data there. When you see a green cell, it is output. And when you see a pink cell, it is the parameterization of the calculator. For example, you want to calculate per hour or per minute or per year or per whatever. Notice that the blue text is explanatory. For example, I'm reading one for runtime, it's the planned production time minus the stop time, where stop time and downtime is the unplanned stops, which are breakdowns, and the planned stops, which are changeovers. So the user knows what exactly they are filling. Let's make some assumptions, first of all. Before we begin calculating, we shouldn't take for granted that everybody who's going to use that, every interested stakeholder knows the exact formulas. Probably, if you are a maintenance professional, you of course know them, but it's not necessary. So in the first step, we calculate a few indices, two indicative, and more can be added, obviously, if needed. We actually got feedback from industrial partners who told us that this part alone was very useful to them. We are using the official formulas that we got from the SMRP book, the Society for Maintenance and Reliability Professionals Book of Knowledge. You see, for example, the overall equipment effectiveness here. And one final comment is that the calculators that we propose here can either be used in series, which means first use calculator 1, take the output and insert it in calculator 2, take the output and insert it in calculator 3, and so forth. There's 7 of them. Or each and every one of them are independent and standalone, so you can use only part of them. So let's have a look at the first one. I'm showing the Excel spreadsheet one because it has a better contrast for presentation reasons. Everybody who is in the business of maintenance know that OEE is just a multiplication of 3 terms: the availability, the performance, and the quality. So in the bottom part, you will see the actual formulas. Availability is runtime over planned production time. Performance is what would the ideal cycle time be times the total count over the runtime. If you don't know what the total count is, look at the blue explanatory texts. You just input 5 numbers and you get the 3 indices and their multiplications, which is the overall equipment effectiveness. If you go to the second one, which is the average direct cost of downtime, it is true that at the managerial level, every plant owner needs to know how much money it costs for every minute, for every hour, or for every time unit that their asset is down. It is very simple. You add employee costs. You can add averages or estimates, units produced by the machine, revenue produced by the machine. So you transpose the output into whatever monetary values or pricing values we have, and you press calculate. This time we see the web form of the calculator, and the average direct cost of downtime is calculated. One note that we would like to make here for those that are very strict with theory. Remember that downtime is not the same as maintenance repair time, because from the time of failure, you have rundown of the machine, preparation, active repair time, assuming that you have the spare parts inventory or just-in-time inventory of the spare parts, and the people who are going to perform the maintenance are available and they don't have to travel. And then you have to restart, ramp up, and reach normal operation again. So we calculate direct cost of downtime, not active repair time, which is the actual metric that managers care about, because this is the period that the machine is not producing money. The third calculator doesn't really calculate, it's an input form that uses the input that you provide in the next steps. So as you do realize, the calculator cannot possibly know the specific of every asset, every production line, every factory. So you have to give it some data first so that it can work. This is obvious and it's obligatory. Notice that the numbers that you will be providing are before you even apply predictive maintenance PdM. So even if you are evaluating or you are considering as a factory manager, what would the benefits be if I were to predict, to install predictive maintenance, we will see that later, you can do this in advance. One clarification, when we talk about an asset, we refer to the actual production line, the machinery that we're trying to optimize. This is a different cost. And we should not confuse it with the cost of the predictive maintenance deployment. This means whatever hardware, software, sensors, and so forth we installed on top of the asset to improve it. So these are two numbers, and we have to pay attention to both of them. And why are we doing all this? Because by definition, whenever you calculate financial indices in any application in the world, from stock markets to whatever, you need an initial investment value to begin with, so that the calculations will have something to divide with. So once you do that, let's see the form, for example. What is the estimated total cost of machinery acquisition? How much does the production line cost to buy it new as an asset value? What is its useful lifetime until obsolescence, until full replacement? This has to do with depreciation, which also has to be used in the calculations. What is the total maintenance expenditure that you are currently paying per year totally without installing predictive maintenance? What is your current status? What is your total cost of spare part inventory and logistics as a sum? And then we need two estimates. One is the average revenue that the particular machine is producing per year, per hour, you can change that. And what could be, even ideally, that can never be reached at 100%, the maximum possible revenue that this machine could yield if everything went perfect and it never broke down and efficiency was 100%. Once you do that, Calculator 4 gives you the total cost of ownership, which by definition is one of the most useful things that managers talk about. So it's also applicable in many other cases beyond PdM, and it will serve as input. Notice that we exclude tax benefits or depreciation or any form of funding. For instance, if you participate in an Horizon 2020 project and you get funded for that, no, this is plain finance. This is only the cost breakdown and the total cost of ownership, which we have divided. In the first section, you will see the initial investment, and in the second section, the recurring per year. And then we break it down in hardware, in expert remuneration and integration cost, training and acquisition, software, licenses, subscriptions, and so forth. This can obviously be the cost of an already implemented PdM or a projected that you are considering in the future. And as I mentioned, it excludes tax benefits, depreciation, or any other form of funding. Then we go to the RAV, the replacement asset value KPI calculator. I would draw your attention in the blue text here, because according to the international paradigm, the RAV, the replacement asset value, is a worldly known benchmark. And when you create ratios over that, you get some very useful KPIs. This term was coined in the 1980s by Toyota manufacturers. And it solves the simple problem of replace or fix, which means if your car starts breaking down very often and the maintenance cost is very high, you're better off, obviously, to throw it away and buy a new one. So the maintenance of a replacement asset value is a metric that depends, of course, on the context and in the industry, but as a general rule, 10 is okay, 5 is good, 3 is excellent, and 1 is best in class. So we calculate various benchmarks, the total cost of ownership of the PdM solution over the RAV, the total maintenance cost or the part of maintenance cost that refers to predictive maintenance, either per replacement asset value or per the asset output. So how much money am I paying as maintenance over how much money am I making as output? And you might note when you use the calculator, I draw your attention in the last blue text, that sometimes you do expect that predictive maintenance can appear to be more costly than corrective maintenance. Of course, and no maintenance at all is cheap, it's free. But the point is that although some ratios might appear smaller, you have to look at the overall benefits that you achieve and the savings you achieve, that we will see in the cost-benefit analysis later on. So these have to be in conjunction and obviously to be taken with a grain of salt. So let's go to one big one, which is calculator number 6, which does two things. It compares the before-after case, and it also gives you a comparison against the so-called best-in-class benchmark, what would be the optimal. And we address two types of users. You can either be someone who doesn't have a predictive maintenance solution, but wants to estimate what would the benefit be if they were to install one in the future, or you might already have a predictive maintenance solution. You have calculated your cost benefit with your own way, and you would like to know what other cost benefit did other deployments achieve? How do you fare against the best in class? Or what would be the optimal to expect? Let's make an interruption here and say that obviously we cannot tell everyone what KPIs they would be using. We have from theory devised the so-called universal predictive maintenance KPI list to provide some ideas. This was based on the EN 15341, out of which in our project we extracted some, and then we refined them, we implemented them in the prototype in Excel files, and then in web forms and scripts, and this is what we did in PROPHESY. But in this list, and we encourage you to visit pdm4industry.eu and have a look at it, you will have a master list of KPIs in 3 categories, either economic or operational efficiency and asset utilization percentages, or maintenance efficiency. And the first addresses the higher level management, and the other two address the middle management and the maintenance engineers. So let's return to the calculator. For the 2 use cases, Jaguar Land Rover and Philips, you will see the 2 tables of what KPIs we had, what was their target, and what was their improvement in month 0, 18, 27, and 36 of the project. And of course, the toughest part, as you can obviously expect, is to translate a KPI into monetary values, which means if I improve, for example, my inventory by 5%, how much money does this imply as a saving? And this obviously has to do with the experience of the owner, because in each factory it's different. who in our case provided a good guess estimate, as our friend Americans used to use the term. So, for example, Philips had their own activity-based costing and their ERP system, and they used this to translate the KPIs into monetary, either costs and savings or improvements in revenue, in money in general terms. So it's not very intelligent. Once you give a reference point, a baseline of the before PdM and the after PdM, you can either have savings in green, or if they're negative, then it turns red. We have accounted for that too, because, for example, in a PdM platform, you increase maintenance cost if you install PdM, but the overall savings are better. And notice that in this specific dummy scenario that I'm showing, the total benefits were calculated to exceed 18% of the total cost of ownership. So imagine this as a payback period. The savings are even a substantial percentage of the replacement asset value of the entire asset. So these are not negligible results. These are very important results. If you want to compare yourself against best in class, and you will see the sliders on the right, we have used the example of other PdM calculators that exist online, the example of bibliography, the example of McKinsey and Accenture Consulting on the subject, as well as other PdM deployments, and of course PROPHESY. We divide some parameters based on the international paradigm, and of course the user can use the sliders to make them higher or lower if they want to achieve a pessimistic or optimistic scenario. But we give you an initial value to begin with. Through that, you can decide if it is worthy for you to install a PdM solution, and you can go the other way around. Set the parameters and see how you compare. So once you do that, on the left you can see a safe scenario, and on the right you can see an optimistic scenario of what savings you can expect in every category, total benefits and percentages. The calculators will give you that. And then you reach the final point, which is to calculate ROI and financial indices. Honestly, this is a useful calculator in general, because finance doesn't change if we have to do with predictive maintenance or anything else, as long as you give cash flows in and cash flows out and weighted average cost of capital and percentages and useful lifetime and so forth. The ROI, IRR, payback, discounted payback, net present value of whatever investment remain the same. So this calculator can be useful outside PdM applications as well. And again, we do not account for benefits in the form of tax deductions or depreciation or example funding from Horizon 2020. This is pure finance in the corporate world. How much money am I paying? How much money am I making back in savings? You can see an indicative output on the left of our ROI financial calculator, which has a payback period of approximately 5 years, or if you take discounted cash flows, a little bit less, 5.04. You can see the Excel version on the right, which has the calculations. Of course, you have to add the weighted average cost of capital of each company, but this is just a rate. And it's nice to play with that and see how it changes if you can have access to funding, which is cheaper. My collaborator, Oscar, from Jaguar Land Rover, will present this slide in his next presentation, but these are the actual values and the cost benefit that we achieved in our use cases in PROPHESY. So we need a 3-year period to achieve a positive ROI, and 4 to 5 to achieve the full benefits. You can see the numbers here. Now, what do we do after we have these numbers? First of all, we could stop here. But let's sum up what we achieved so far and let's explain the next step. Assume you have some well-defined KPIs and you calculated your indices and you have an analytic cost breakdown, because if you don't know your cost breakdown, no calculation can work. You can calculate the asset value, the replacement asset value, translate your KPIs into monetary estimates. We think it's more important that you can estimate for new deployments and persuade more people to come into the world of predictive maintenance. And secondarily, to make simple subtractions, what was the status before and what was after. Of course, it's useful as well, but not so much in our opinion. So we have a so-called SOE, a service optimization engine. This is another web tool that you can find in our ecosystem, which is the final step. You see snapshots here, and it's also free to use. Please feel free to join and try it. Let me explain what it does. Assume, technically, that you have a solution that comprises of modules. We call them service bricks, and you see in the slide below, every square is a different service brick that PROPHESY has created, from data streaming infrastructure, from root cause analysis, machine learning algorithms, from the asset administration cell as dictated by Industry 4.0 RAMI model, and so forth. You have to put them together. You can play with them in our Play with PROPHESY solution, where it says try it, but where we have actually a sandbox demo for visitors, but this is not the concept here. In financial terms, imagine that you have all these and you start combining them in a chain of nodes, categories. So let's say I have data collection modules, which then give input to data analytics modules, who then give input to one or two or more modeling modules, who, following management and security and other managerial modules, give output to a visualization module. Each of them has some properties. You can see them on the right. From financial properties, CapEx, OpEx, total cost of ownership, or qualitative properties. So ranking of how easy it is to deploy it and how much time it takes to deploy it, with weighted rankings from 1 to 5. And also consider that these are interchangeable, so you can remove one data analytics algorithm and replace it with another one, which probably gives a better confidence interval. And you want to try what's going on. Well, the SOE, that's why it's called an optimization engine, based on criteria that you see on the right, either quantitative, numbers, money, or qualitative, as I mentioned, ranked. And operators, I want the maximum, I want the minimum, I want the minimax criterion, I want the threshold above. So the simplest solution, tell me which of the solutions has the lowest total cost of ownership. It might not be the best one, but it definitely is the cheapest one to own. Or tell me which modeling combination gives me the best benefit estimate. Then SOE will calculate and give you this optimization table with the service bricks, i.e. the constituents of your solution that you chose. And the good thing is that you can have solution comparison. How does one solution fare against the other? And a feature that we are currently implementing now, and it should be available approximately next week. Users can import their own table, so you don't have to be a member of PROPHESY. Whatever service bricks or module your solution comprises of, in whatever categories, with whatever properties you put in the table, the SOE will also optimize for you based on whatever you give it. So that was my presentation. I invite you all to visit pdm4industry.eu, join for free. Thank you for your time. My name is Giannis Kaldis, and you can reach me by email or whatever else you require. Thank you.
Thank you, Giannis. I have already a question from the audience. In fact, for those that are following, if you have already questions for our speakers, you may address them through the Q&A box that you have in the interface. I think it's better to address this question to you. It's from Heye. So he's asking, you see that, Giannis, apart from the use cases from the PROPHESY project, did you receive feedback from external users on these calculators for predictive maintenance ROI?
Yes, this is a very nice question. I like it very much. Actually, through our exploitation phases, we gathered all our partners and we invited them to find not from academia and research and theory, actual industrial partners from their pre-existing networks of clients, vendors, negotiators, so that everybody would yield at least 5 or 6. We ended up having 66 companies from the industry that we contacted. We didn't just present the project, we presented these calculators and these tools. We got feedback from them. We managed to have them join in our ecosystem. And I can tell you that the comparison, for example, was an idea from one of the industrial partners. It wasn't ours. They told us to do it and we implemented it. So yes, this was a very nice question. Thank you very much.
Yeah, thanks also to Heye for the question. I mean, we'll be having more time by the end. I have just like a follow-up. So which were these results compared between the internal use cases and the external? There were a lot of differences in the results, or I don't know if you can just tell us more about this.
No, you mean internally? I'm just presenting. I gave you the real numbers of PROPHESY in the table. And that Oscar will also give you. The others are just dummy variables that I gave in order to explain the usage of the calculators.
Yes.
Because as you understand, for privacy and sensitivity reasons, we cannot provide the actual cost of a particular service brick. We can, of course, provide, and we gave it in our confidential report to the Commission, the actual ROI and the actual benefit. This we are giving, and we give it to you in public. Yeah. But for demonstration purposes, I just used dummy numbers. Don't lose sight of the fact, though, that the calculators still work. If you add any number, the calculator just gives you the answers. Okay, so thank you for this question.
Absolutely. Perfect, Giannis. So thank you very much. In fact, you were speaking about Oscar's numbers at Jaguar Land Rover. In fact, he's the second speaker of today. He will be presenting the results of the PROPHESY project applied to their use case. So Oscar, when you want, you can also start your presentation.
Thank you very much.